Hi, today we're going to talk about basic navigation in WispPlanner.com. So to start, when you first log in, you'll find yourself looking at something that looks like this, a basic Google Maps style interface with a control bar at the top and main navigation on the left. Just like Google Maps, you can click and drag to pan around, or use your mouse wheel, or click the zoom controls to zoom in and out. There are a number of different base maps available. You can switch to a 2D renderer to stop using your GPU. That's a good choice if you're on a slower computer. Go back to the 3D view. You can switch to an OpenStreetMap view or a Google Maps view. You can switch to Google Terrain, which does a good job of showing you where the terrain actually is. You can switch back to regular overhead or satellite view. Let's go ahead and zoom close to my Paquin Tower. You'll notice that once you start getting in close, building outlines start to be rendered. We've actually got a pretty sizable database of building outlines all over North America at this point, derived from a few different sources, and they're quite integral to the way we run calculations. But sometimes it's not what you want to see. You want to see the base map. So you click this button here and the buildings are gone. Click it again and they come back. You can also, at any time, click this little icon down here and switch to a tilted 3D view. You can also right drag to pan and rotate the map, a lot like working with Google Earth. This is great because we're actually applying altitude to both the base map and the buildings. This gives you an instant feel for what your map actually looks like. So, zooming back out, now we know how to access the basic map. What's up with the building colors? Well, if you run a path profile to a building and it succeeds, we color code the building green for future reference so you know where service is possible. You can also, at any point, click this icon, the circle, to start showing radius rings. If I zoom in, we have a pretty sizable network. We're mapping all of it, and now you can see what radius we've applied for each of our towers. It's also often handy when you're looking at a map to know where your customers already are. For example, somebody calls in wanting service and you know their neighbor has it. That often makes the decision a lot easier. You can sync with UISP and LibreQoS Insight to start rendering your clients on the map. We're hoping this integration will be available very soon. Wisp Planner also allows you to search easily. You can type a tower name and it pans straight to the tower. You can search a customer name or type an address. I'll type my old office because that address has been available for years. It zooms right in and finds it. So, what happens when I click a building? It pulls up a building panel showing the building in detail with the roof scanned in segments. We actually procedurally analyze every pixel along the roof to determine which parts are probably covered by foliage rather than rooftops by looking for variance levels within each of them. We then use the defined antenna height above the roof and the antenna models configured for nearby towers to run path plots for each pixel on the building. This gives you an almost immediate answer. Can I install here? Is it going to work? And which part of the roof do I need to go to? But that's probably not enough information. Here, we see an estimate of minus 51 dBm. Let's make sure we understand how it got to that number, so we click on the tile. You'll notice the path appears on the map here. We'll look at that in a second. We zoom out. It's showing currently that we're modeling to a 2.4 gigahertz antenna. This is a list of all the services we find that might align. You can see here it might connect to our 2.4 GHz sector on Pakwin, but there's an obstruction. If we zoom out, you can see we're showing the path line. Switch to a tilted view. You can now see where it's going, but that doesn't really tell you exactly what's going wrong. One way to investigate is by dragging your mouse along the markers up here. So you can see the obstructions are actually mapped closer to the customer. There it is. You can see it's starting to intersect with that building. But sometimes you want a much more detailed picture. At that point, you can click the Open 3D Terrain, wait a second while it maps in all of the data at 0.5 meter resolution from LiDAR. We have that for the majority of the United States now. And now we have an almost Minecraft-like view. We can zoom around. You can see we plotted balloons showing the size of each of the Fresnel zones. For this particular service, we have quite accurate LiDAR coverage showing you exactly what's there. It's filtered so power lines don't turn into walls in the sky. The detail is sufficient to pick out many recognizable shapes. We add red markers, showing you where obstructions occur. In this case, it looks like we're clipping some foliage next to a building. That is exactly the sort of thing you need to know when determining whether you can provide service to this rooftop. So, in this video, we've covered navigation. We've covered using 3D, zooming, panning, plotting buildings and paths. You don't have to click on a building to pull up the terrain profile. You can also pick a location. Let's randomly choose this parking lot. It's a parking lot. I can't imagine the service is going to be too great. There's a short delay because it's evaluating every in-range tower in service, building each path at 0.5 meter resolution. You can see we have spectacularly bad service because this parking lot's on a hill. It's not going to work. That's the sort of thing you need to know when running a WISP. To learn more about WISP Planner, please visit wispplanner.com.